Alright, in this video we're going to take a look at an example of solving an equation that involves fractional expressions. Alright, so the equation we have is 3 over x minus 2 over x minus 3 equals negative 12 over x squared minus 9. Alright, so I did a video on solving linear equations where we solved a linear equation that involved fractions as like coefficients. So if you watch that video, we're going to use the same basic principle here where we're going to find the common denominator of all our fractions and then multiply both sides of the equation by that common denominator to eliminate all of our fractions. Alright, so the first step when you're solving an equation that involves fractions of any type, right? In that linear equations one, the fractions were it was like a 1/2 x and a 1/3 x. That same method applies here, even though our fractions now have x's in the denominators, we can still use that same method to try to figure it out. Alright, so first thing I need to do is factor my denominators if I can to try to help figure out what my common denominator is going to be. So I have a 3 over x. I can't do anything with that x, right? That can't be factored. That's just an x. I have the 2 over x minus 3, also cannot be factored. There's nothing I can do with an x minus 3. But this fraction on the right side, this negative 12 over x squared minus 9, I can factor the x squared minus 9. Right? That is a difference of squares, and so that factors into x plus 3 times x minus 3. All right, so we factor whatever denominators are able to be factored, we factor those, and then we put together our common denominator by basically taking one of each factor that we have in our denominators, right? So this fraction has a factor of x in the denominator. So up over here, I'm just going to, like on the side, write my common denominator. It's going to have an x. It's going to have a factor of x minus 3 from this fraction. It's going to have a factor of x plus 3 from this fraction. Right, and this x minus 3 factor, well, I already have that one included, so I don't need to put that one in there again, because that x minus 3 factor was already included from this fraction over here. Right, so my common denominator is going to be x times x minus 3 times x plus 3. All right, that's the common denominator for all three of my fractions. All right, now, what I'm going to do with that is I'm not going to convert every single fraction into a common denominator and then work with those fractions all through the problem. That kind of makes this messier than it needs to be. What I'm going to do is multiply that common denominator on both sides of the equation. All right, so I'm going to multiply this common denominator by every single term that I have in my equation, and when I do that, if I did it correctly, it should cancel out all of my fractions. All right, so I'm going to take the common denominator of x times x minus 3 times x plus 3 and multiply that times my first term, which is 3 over x, and then minus, and then my common denominator again, x times x minus 3 times x plus 3, and multiply that by my next fraction, which is 2 over x minus 3. I'm going to have to go down here to write the last part, and then equals, and then my common denominator again. Remember, I can multiply anything as long as I do it on both sides of the equation. So I multiply that common denominator by everything on the left side of the equation, and then the equal sign, and I multiply that same common denominator, x times x minus 3 times x plus 3, times what I have on the right side of the equation, which is that negative 12 over x plus 3, x minus 3. Alright, so what did that accomplish? It looks like it made my equation way more complicated than what it was before, because now I got all this extra stuff in there that I didn't have before. But what ends up happening here, since I'm multiplying this common denominator times the fraction, this denominator of x gets canceled out by that factor of x that's in my common denominator. So what I end up with then is the 3 times the x minus 3 times the x plus 3. All right, so that first term, that x in the denominator gets canceled out, and those other terms from my common denominator now get multiplied by that 3 that I had before. Right? Same thing's going to happen in my next term. Right? This denominator of x minus 3 is going to get canceled out by the x minus 3 factor of my common denominator. So it's going to be minus, and I have a 2 times x times the x plus 3 factor. All right? And then that's going to equal, and once again, I'm going to put that other side of the equation down below. That's going to equal, and then in this fraction from the other side of the equation, the denominator of x plus 3, x minus 3, the x plus 3 factor gets canceled out, the x minus 3 factor gets canceled out, and all I'm left with, and actually I can fit this up above here, is going to equal that negative 12 times x. Right? And when I multiply both sides of the equation by that common denominator, all of my fractions disappear. Right? So that's the best method to use in my opinion, is the best method to use when you're dealing with any type of equation that involves fractions. It doesn't matter what those fractions look like. If you multiply both sides of the equation by your common denominator, it will eliminate all the fractions, right? And now what I'm going to have to do here is erase some of the stuff up above just so I have room to do the rest of this equation. All right, so I'm just going to copy this up here and then work to solve this equation that we end up with. So I end up with a 3 times x minus 3 times x plus 3 minus 2x times x plus 3. And then that equals negative 12x. All right, so that's what I get from multiplying out my common denominator and canceling all the fractions. And now I have an equation that does not involve fractions, so now I can just go ahead and solve the equation that I'm left with from here. All right, so that's the key thing when you're solving an equation that involves fractional expressions. Multiply the common denominator, cancel all those denominators out, get rid of those fractions so you don't have to deal with them the whole rest of the way. All right, and now what I need to do, though, is multiply all this stuff out and combine like terms and see what type of equation I actually have here, because I have kind of a mess of stuff, which happens when you end up with fractional expressions with x's in the denominators. A lot of times it turns into a kind of a messy equation. All right, messy, but not impossible, right? We can still do this. All right, so the first thing I'm going to do here is multiply this x minus 3 times this x plus 3. All right, and if I do all that, I'm going to have the 3 on the outside still, and that's going to be the x squared minus 9 that I started with here. All right, so x times x is x squared. When I do the inner and outer terms, I get a plus 3x and a minus 3x, which cancel out, and then the negative 3 times 3 gives me the negative 9. Right, if I distribute that minus 2x into the parentheses, it's going to be minus 2x squared minus 6x, and then equals negative 12x on the other side. All right, so at this point, once I eliminate all those fractions, now it's just a matter of simplifying, combining like terms, doing everything I can to see and to make this equation as simple as possible. Right now, I'm going to distribute this 3 into this parenthesis, so that's going to be a 3x squared minus 27, and then minus 2x squared minus 6x equals negative 12x. All right, and now I want to start combining like terms, and it looks like I'm going to have a quadratic equation here, because I have a couple x squared terms, which are not going to cancel each other out. So since I'm going to have a quadratic equation, let me move everything to the same side. So let me add this 12x over to the right side, and I'll combine it with its like term, over to the left side, and I'll combine it with its like term, which is that negative 6x there. All right, so my x squared terms, I have a 3x squared minus 2x squared. That's going to be a 1x squared. And then I have a minus 6x plus 12x, so that's going to be plus 6x. And then I have a minus 27 equal to 0. All right, so from this ridiculous equation that I started with these fractional expressions, to canceling out the denominators to get this ridiculous equation that I got, and then simplifying all that, it comes down to a pretty tame quadratic equation, right? X squared plus 6x minus 27, that doesn't look that hard to solve if we are familiar with the methods for solving quadratic equations, right? And I did some videos on solving quadratics by factoring and using the quadratic formula and the square root method. So if you haven't seen those yet, we're going to use one of those methods to solve this equation here. Right, so you might want to check out those videos if you haven't seen them yet. And once again, though, I'm going to have to erase this stuff up above to have enough room to finish off this equation. But we should be pretty close to the end right now. All right, so let me just rewrite this up here. All right, so x squared plus 6x minus 27 equals 0. All right, so what I end up with is a quadratic equation. Right, my quadratic expression is a trinomial. Right, there's 3 terms. It's a 1x squared, and it looks like I might be able to factor this. Right, remember, factoring as a method for solving quadratic equations, it doesn't always work. But if it does work, it's probably going to be quicker and easier than using the quadratic formula. So if it looks like I can factor it, I'm going to try to factor it. And if I can't figure out how to factor it, then I'll fall back on doing the quadratic formula. But since this one is a 1x squared, it's worth taking the time to at least try to factor it. All right, so the x squared, I break up into x times x. And then I look for 2 numbers that multiply to equal negative 27 and add up to equal positive 6. Well, 27 is 9 times 3. And since it has to be negative, I need to make one of those negative to add up to a positive 6. So if I make it a plus 9 and a minus 3, positive 9 times negative 3 is negative 27. Positive 9 minus 3 equals positive 6. Right? Remember, the reason we do that is because when we FOIL this back together, those middle terms, or the inner and outer terms, the plus 9x and the minus 3x, have to add up to that plus 6x that we have in the middle. And then the last terms, the 9 times negative 3, have to multiply to give us the negative 27, which they do, which means that we have our factoring. And now that we factor this, we can go ahead and solve by separating our factors. All right, so x plus 9 equals 0. When I subtract 9 on both sides, I get x equals negative 9 as a solution. And my other factor, x minus 3 equals 0. When I add 3 to the other side, I get x equals positive 3 as another solution. All right, so I end up with 2 solutions to this equation. Right now, one thing to be aware of, and you think you're done with this problem, like, oh, finally I got my 2 solutions. This was kind of a rough problem because there was a lot of stuff I had to do here, but we're still not done yet, unfortunately. Anytime you're solving an equation that starts off as not being a quadratic equation, like this one here was not a quadratic equation, right? It was an equation with a bunch of fractions and stuff in there. But as you're solving that, if it turns into a quadratic equation like this one did up here, sometimes the answers you get don't actually solve the original equation, right? These are the 2 solutions of x squared plus 6x minus 27 equals 0. It doesn't necessarily mean that both of these numbers are going to solve this original equation that we started with, right? So what you need to do after you get your solution to these equations, if it somehow turned into a quadratic equation, you need to check to make sure your answers actually work. All right, so let's check to make sure the answers actually work. And once again, I'm going to have to erase some of this stuff here. All right, so the 2 answers we got were x equals negative 9 and x equals 3. And maybe I should write that negative 9 so you can actually see what it says. All right, so those are the 2 solutions that I got. All right, so let me test them out. So I plug in x equals negative 9 into my original equation. So it's 3 over negative 9 minus 2 over negative 9 minus 3 equals negative 12 over negative 9 squared minus 9. And now I have to double check that this is actually equal. Right? And my advice on this one would be to put all this stuff into a calculator and just do the left side and see what that equals, and then do the right side and make sure it comes out to equal the same number. All right, so it's going to be negative 1/3 minus, that's going to be 2 over negative 12. So that's going to be plus 1/6 equals, and really there's a question mark on this equals here because we're not sure if this is equal or not, over 81 minus 9, which is going to be 72. So negative 1/3 plus 1/6 is going to be negative 1/6, and 12 over 72 is 1/6. So negative 1/6 does equal negative 1/6, and so x equals negative 9 is a good solution to this equation. I plugged it in on both sides, I get the same number on both sides. And if you didn't quite follow me of everything I did there, I just kind of did that kind of quick. But I'm adding fractions together and doing common denominators and stuff. I've done that stuff so much that I can just kind of look at it and figure out what it is. You might have to do a little work there. Or like I said, if you have a calculator handy, you can just put this stuff into the calculator and see that it comes out to the same number in the end. All right, so negative 9 works as a solution. What about x equals 3? Let me leave that up there. So if I plug in x equals 3, 3 over 3 minus 2 over 3 minus 3, does that equal negative 12 over 3 squared minus 9? Well, already I see a problem, right? The 3 over 3, that equals 1, that's fine. This 2 here over 3 minus 3, well, 3 minus 3 equals 0. I can't have 0 in the denominator of a fraction. That is not allowed, right? So it doesn't even make sense to plug x equals 3 into this equation. It gives me a 0 in the denominator, so I can't plug in x equals 3, right? This is no good. X equals 3 is what we call an extraneous solution, right? Extraneous meaning extra, right? That is an extraneous solution. It is not a solution to this original equation, right? It solved that quadratic equation that we ended up with, but it does not solve our original equation because it actually gives us zeros in the denominators. We cannot plug x equals 3 into that equation at all. So it can't possibly solve the equation if I can't even plug it in. All right, so again, the lesson here, there's a couple things for this problem. One, when you're dealing with the fractional expressions, you got to multiply by the common denominator to cancel out all the fractions, and then just deal with whatever type of equation you end up with. You just got to deal with it and work through it to solve it. If you end up with a quadratic equation that you have to solve and you get 2 solutions for it, you do have to check those solutions in the original equation to make sure they actually work. As we saw here, one of those solutions did, the other one did not. If we say that the solution to this equation is x equals negative 9 and x equals 3, we're only partially correct, right? X equals 3 is actually not a solution, so you have to check your answers when your equation turns into a quadratic equation. Very important thing to remember.